Okay, in this example, they want us to draw the graph and identify the range using the same notation as the domain. So to draw the graph, I'm going to make a little coordinate plane here. And the only x values that we can substitute into this function are the ones within this range. So I'm going to start with the -1, and I'm going to substitute that into the function. So if I substitute -1 in for x, that's going to give me -2 minus 1, which is -3. So the coordinate that I'm going to plot here, so the x value that I used, so my x value was -1, that's what I substituted in. The y value that I got was the -3 here. So -1, -3 needs to be plotted on this graph. So -1, -3 is going to be there. Then I'll also plot the 2. So let me substitute 2 into the function. So that gives me 4 minus 1, which is +3. So when my x value is 2, my y value is 3. Now for this point at 2, 3, it has to be an open circle because of the parenthesis here. So at 2, 3, I'm going to put an open circle. And then this is just a line because it's linear. It's x to the first power here. So I'm just going to connect these dots. So I've drawn the graph. Then it wants me to identify the range using the same notation as the domain. So the domain is written as an interval. So the range, remember, is the y values. So the lowest y value on this graph is the y value here, which is at -3. So -3 would be the first part of the interval. The highest y value, here's the highest point on the graph. The y value here is at +3. And then since this is a closed circle, I'm using a bracket. Since this is an open circle, parenthesis. So let's do another one of those. Okay, this time our function is 1/4 x minus 1, and we're given a domain of -4 to 4. So again, I'll draw a little coordinate plane here. And I'm going to substitute these x values in and see what I get for my y value. So 1/4, I'm going to replace the x with the -4. It's my left bound. So whenever I evaluate that, if I multiply these together, I would get -1 minus 1 would be -2. So when my x value is -4, I get a y value of -2. So I'm going to go ahead and plot that point. So -4, -2. -4, -2. And both of these are going to be closed circles because we got square brackets on both bounds. So sorry, maybe couldn't see that. So here's -4, -2. And then next I'll substitute in the 4. So when I multiply these together, that would give me 1. 1 minus 1 is 0. So when x is 4, my y value is 0. So 4, 0 would be here. And again, it's a linear function, so I can just connect these points like that. Now I'm going to write the range. Again, it's an interval, so I'm going to write the range as an interval. So the lowest y value here is, or the lowest point is here. The y value is at -2. And then the highest y value would be the y value here. It's the highest point on the graph, and that y value is 0. Square brackets, because those are both closed circles. So, oh, sorry, you couldn't see that. -2 to 0. All right, let's do one more. So this time, our graph will have a point, function. Our function is going to be 4/3 x minus 3. This time the domain is given to us in set notation. So squiggly bar x such that x is less than 3. All right, so we only have one bound here at 3. And think about what x less than 3 is. So I'm just going to draw a little graph here. So here's 3. Less than 3 would be going like this. So it may be helpful to think about this as an interval. So really the domain is going from negative infinity to 3, like that. So let's start by substituting 3 into the function. So 4/3 times 3 minus 3. If I evaluate that, this is going to give me 4 minus 3, which is 1. So my x value was the 3 that I substituted in. My y value is the 1. So 3, 1 is the point that I will plot first. And it's going to be an open circle because it's a parenthesis here. It was strictly less than, so we can't include the 3. So open circle, and then you can only choose x's less than 3, so just pick any x less than 3, like 0 would be less than 3. So I'm going to substitute 0 in, because that's a nice number to evaluate. When I substitute 0 in, I would get 0 minus 3, which is negative 3. So when x is 0, my y value is negative 3. So that would be down here. Another way you could do it, if you don't like to evaluate another point, is just think about the slope of this graph, which is 4/3. So from this point, I could go down 4 units and then over 3, and that puts me in that same spot. And so I will connect these dots, but this time I have an arrow because we didn't have 2 boundaries. We just had the 1 boundary. There's my graph. So we need to think about the range on this thing. And so the range is going from negative infinity all the way up to 1, because the lowest y value would be the arrow right here. So my range, really the easiest way to write it would be that all your y values are less than 1, because this is the highest point on the graph, and that's at positive 1. All y values are below that, so y is less than 1. Of course, they want it in the same notation as the domain, so I really need to write that in set notation. Like that. That would be my answer. So in this example, go ahead and draw the coordinate plane with the graph. We're identifying maximum values, minimum values, and zeros. So if you're ever talking about maximum values, those are like the hills or the mountain peaks on the graph. So max values, those are our hills. Minimum values, those are our valleys. And zeros, it's where it hits the x-axis. So where it hits the x-axis. Okay, so if I'm looking at this graph, I see a couple of hills. I see a hill right here, and I see a hill right here. So the maximum values are the y-coordinates. So it's the y-coordinate of the hills. And the minimum values are the y-coordinates of the valleys. So y-coordinates of the valleys. So the y-coordinate of this hill is at 3. So one maximum value would be 3. Another maximum value would be the y-coordinate here, which is at 2. Those would be your maximum values. Minimum values would be the y-coordinates of your valleys. And I see 2 valleys here. Here's one valley, and here's another valley. So my y-coordinate here is at -1, so that would be a minimum value. And then the y-coordinate here is at -3. And then the zeros, that's where it's crossing the x-axis, which is the horizontal axis here. So I see that it crosses here, it crosses here, it crosses here. Don't be tricked by this. There's not an actual dot there, but it's a smooth curve, so there really is one. It's just not drawn. And here. So it's crossing the x-axis 1, 2, 3, 4, 5 times. So my zeros, let's see, the x-coordinate here is -1, -2, -3, -4. The x-coordinate here, it looks like it's in between -2 and -3, so I'm going to say -2.5. The x-coordinate here is -1, the x-coordinate here is 1, and then at 4. So it had several zeros. And then you may also be asked to find the average rate of change between 2 x values. So I'll just say the average rate of change between x equals -2 and x equals 1. So if you ever see this phrase, average rate of change, just know that that's the same thing as slope. And I don't know if you remember the slope formula, but it is y2 minus y1 over x2 minus x1. You just subtract the y, subtract the x's, and then divide. So we know the two x values. So the first thing you have to do in this problem is get the y coordinate pair. So when x is -2, my y value is, let's see, so when x is -2, the y coordinate here is at -1. And then when x is 1, my y coordinate is, let's see, here's when x is 1, my y value here would be 0. And then we'll substitute these into the formula. Doesn't matter which one you make, x1 or x2, so I'll just make this x1 and y1, I'll make this x2 and y2, and then you just substitute it into the formula. So y2 minus y1 would be 0 minus -1. In my denominator, I just do x2 minus x1, so x2 is the 1, x1 is the -2, and I just evaluate this. Now, there's several ways you can evaluate it. You can just do it in your head because it's not that hard. 0 minus -1 is 1. This is 1. Since it's minus -2, it becomes a plus, so you get 1/3. But let me show you a trick you can do on the calculator. So to get this fraction bar, you can hit the alpha button, which is that green button. You can hit y equals, and then hit enter. It pulls up this nice little fraction bar. So I can do 0 minus -1 in the numerator, 1 minus -2 in the denominator, and it gives me 1/3, like that. So feel free to use the calculator if you want. But this is the average rate of change, which basically what that means is if I looked from x equals -2 to 1, if I go from this point to this point, it's basically saying what is the slope between those 2 points. And so you can actually even see that it would be 1/3, because to get from here to here, I would go up 1 unit and over 3 units. So that's how you've probably talked about slope in the past.